Hi everyone. So now we are going to start studying about antenna array. But before starting the lecture, I just want to clarify one mistake from my side. So in the previous video, I called this angle as azimuthal angle, right? This is z-axis, y-axis, x-axis. So the angle measured from y-axis, I was calling that azimuthal angle, but that is known as polar angle. That was my mistake. Okay, so from now onwards, you will mark this thing. Previously, I said that it is azimuthal angle, but that was a mistake from my side. This is known as polar angle. And the phi is known as azimuthal angle. What is phi? Phi is the angle from x-axis. So this is known as azimuthal angle. So that was an error from my side. So from now onwards, I will call it polar angle only. So that was one of the mistake. I was calling it again and again azimuthal angle, but azimuthal angle is the angle measured from x-axis and polar angle is the angle measured from y-axis. And here, what is ax dot ar? If you remember, if you have studied your coordinate system, then what is ax dot ar? So what is x? X is equals to, this is your r, this distance is your r sin theta cos phi, sin theta cos phi. So if you do ax dot ar, what you will get? Sin theta cos phi, right? And what is y? Y is r sin theta sin phi. So here sin theta sin phi. And what is az dot ar? From here only you can see it is cos theta, right? So these may be used in your analysis. So that's why I am writing it. If you haven't studied coordinate system, then at least you need to remember this thing. Try remembering it. Even if you are not able to remember, then also you will be able to solve it. No issue. So this is just a error from my side that I am modifying. Now let's start our chapter, that is antenna array. So till now what we have studied? We have studied antenna theory, right? There was we started with a different kind of antenna, Hertzian dipole antenna, linear dipole antenna. So there were only one antenna. Because of that antenna, at a certain point P, at distance r, at far field point P, we were finding E, H, P average and P radiated. Then we said that there are different kind of antenna, Hertzian dipole, linear dipole, and then we took the receiver as well. So there is receiving antenna and then there is a receiving antenna. So we will provide Vi, it will give us EH. This EH will be taken by the receiving antenna and it will give us Vi. So till now we were taking only one antenna in action. No? Only one antenna was there. Like this kind of structure we were seeing. That at this point P, what will be the electric field? That would have the theta component. And how we used to write down that electric field? We used to say that between the arms of antenna and AR cap, the angle is theta. So let's just say this is Hertzian dipole antenna. So what will be the electric field? Neta into ideal sin theta. What is theta here? Theta is the angle between the arms of antenna and AR cap, and that is equals to the polar angle. That is equals to the polar angle. So neta ideal sin theta upon 4 pi r into j beta into e to the power minus j beta r a theta cap. So this was the expression. Now in this chapter, how I will denote this particular antenna? I will denote this particular antenna as an array. Sorry, as an arrow, not as an array. I will show it as an arrow. So if I have made this arrow, then you will realize that there is an antenna which is placed like this. There is an antenna which is placed like this. So if I am making the arrow upward, that means antenna is placed like this. Now if arrow is going upward or downward, that doesn't matter. If arrow is going upward or downward, that doesn't matter. But mostly in your question paper or in the textbook, you will find the arrow to be upward. Okay, and if it is downward, then what is the meaning of that? That also I will tell you. So the direction of arrow doesn't matter. Whether you make it downward, whether you make it upward, that doesn't matter. So if you have just made an arrow, that means it is an antenna only. Okay, this antenna has been shown like this. And then what I can say, at a distance r, at point P, what will be the electric field? So what you will do, you need to measure the antenna you need to measure an angle which is between the arms of antenna and AR cap. This is your AR cap, this is the arm of antenna. So this angle I need to measure. That's it. So this is my theta angle, and same expression I can write. Basically, this scenario or this particular structure can be made like this as well. So this is what I wanted to tell, right? Let's make more structure. If it is placed like this, if the antenna is placed like this, then how I can replace it? With an arrow. With an arrow, I can replace it like this. Now, if you make arrow this side or this side, that doesn't matter. But mostly we make the arrow this side. Okay. So that doesn't matter. You can show the direction of arrow anywhere. But mostly we show it towards the positive. Here it would be positive y. And if I made the arrow like this, it would be negative y. So mostly it is shown towards the positive direction only. But there is no hard and fast rule. So this antenna, which is lying on y-axis, has been shown like an arrow. So this is lying on y-axis. This is lying on Z axis. Antenna is lying on Z axis. So arms of antenna is lying on Z axis. Here arms of antenna is lying on Y axis. So if I have made this particular structure, then you will be able to know that what is the actual structure. If I have made this structure, then you would get to know that actual structure is this, right? And at point P, at distance R, I need to find the electric field. So what will be the electric field? I hope you should be able to write it down. What that would be? Neta ideal upon 4 pi r. Here what will come? Sin theta. But what is theta? Theta is the angle between the arms of antenna and AR cap. So I need to write down this angle. Which angle I need to write down here? I need to write down this angle. And what is this angle? This angle is our polar angle, which is theta only. This is a universal angle, polar angle. When we study our coordinate system, when we study our spherical coordinate system, so what do we say? Angle measured from z-axis is known as theta. So angle measured from z-axis is known as theta only. But what we need to write down here? We need to write down the angle between the arms of antenna and AR cap, and that is 90 minus theta. So here I will write down 90 minus theta. So ideal sin 90 minus theta upon 4 pi r into j beta e to the power minus j beta r AR cap. And what is sin 90 minus theta? That is cos theta. So sometimes in the textbook you will find out cos theta is written. Sometimes in the textbook you will find out sin theta is written. So if cos theta is written, that means they are taking theta to be the angle made from z axis. Okay. So a particular angle I am going to take, like the general angle. General angle is the angle which is measured from z axis is known as theta, or we call it polar angle, or the angle measured from x axis is your phi. But you need to know what you write down. What you write down here. You write down here, you write down the angle between the arms of antenna and AR cap, and that would be 90 minus theta. A very, very important point when we were studying about our Hudson dipole. At that time also I told you this point, that a lot of guys will do error in this analysis, and now the antenna array will be very easy for you. And if you don't understand this analysis, then it becomes very difficult. People always get confused, right? But now it is clear. So if this structure is shown or this structure is shown, I will be able to write down. And now here what will be the angle I need to write down? I need to write down the angle between the arms of antenna. This is the arm of antenna, and this is my AR cap, and that would be this 90 minus theta. Sorry, this is not theta. This angle is 90 minus theta. Well and good. So this is how I can write down. Now from here onwards we are starting our antenna array. So till now what we were seeing, one antenna, here also one antenna, here also one antenna, here also one antenna. Now there are two antennas. One antenna is placed about D height. One antenna is placed about D1 height from the origin, and one antenna is placed downward D2 height from the origin. So one antenna is placed here and one antenna is placed here. This is your D1 and this is your D2. Okay. So how will I make it? So I can make two arrows. Now like someone will say that, sir, whether I should start my arrow from here, or should I start my arrow from downward, or should I start from the middle? So mostly in the textbook as well and in the examination as well, the arrow is started from here. Now you wouldn't say that, sir, this tip and this tip will have some distance d1 plus x. No, at d1 distance antenna is lying, that's it. So you don't need to think about the length of antenna. Are you getting my point? At d1 distance my antenna is starting, that's it. Okay, at d1 distance my antenna would start. So don't think about the length of antenna. And other thing, if this arrow is I am showing upward, this arrow also I will show upward only. So this arrow also I am gonna show upward only. So this is my other antenna. Now how much current this antenna is having? I naught. Peak current only I am writing, and how much peak current this antenna is having? I naught only. So both currents are same and both are in the same direction, right? Is that clear? Let's go to the next slide. Here the same structure is there. At d1 height you are having one antenna, and at d2 height you are having the other antenna. But now the current values are different. This is having I naught and this is having minus I naught. So what is the way of showing it? That you make this arrow upward, and this arrow you also make upward only. So this current is I naught, this current is minus I naught. And if I had made this arrow downward, what I mean to say is that if I had made this arrow like this, then what I would be writing down here? I naught only. Because if this is having current in upward direction, that means let's just say if if in this antenna the current is flowing like this, then in this antenna current would be flowing in opposite direction, because they are opposite in phase. Are you getting this point? So this is how it can be shown as well. There are two ways of showing it. And what could be the other way? Other way also I am showing that this is your I naught, and here also you can show I naught only. This is your I naught, but here you will show the phase. You can either write minus I naught, or you can write down I naught having the phase of pi. Because if minus is there, that means phase of pi, right? Till now you would be comfortable with this thing, that what is the phase here. So phase of pi is there because minus sign is there, right? Let's talk about this one. So what you will talk about, how you will see it. Now what will be the electric field because of these two, that we are going to find out. Don't worry about that. Here we wrote down the electric field, but in this case we did not write down the electric field. This is our chapter actually. This is our chapter where we need to find out the electric field because of two components now. Here we are finding because of one component only, but now we are having two components. So this is our chapter. This is our whole concept. So at D1 height, you are having I naught. This is also D1 only. Downward also there is D1 only. Or let's make it D2. And at D2 height also you are having I naught current only. But if this is I naught, then this is I naught e to the power j pi by 3. Say yes or no. If this is I naught, then this is pi by 3 ahead of this current. So I am writing I naught e to the power j pi by 3. Now what could be the other way of writing? The other way could be, if I call this as I naught, then what I would be calling this as? I naught e to the power minus j pi by 3. You can take reference of anyone, but you need to see the lag and lead. So this current is leading this current by pi by 3. So here this current is leading this current by pi by 3, because this is having 0 phase and this is having minus pi by 3 phase. That means this is leading. So this is the other way of writing it down. But the most famous one is that which is having 0 phase, that will be written as I naught, and the one which is having some other phase, then that will be written with the phase only. But in the examination, how it will be mentioned? In the examination, they will not give the current expression. They will say that this current lags behind by pi by 3. This is how they can say, or they can say that this current is leading by pi by 3. Okay. So this is what they can say in the examination. So in the examination, statement wise, you will understand the problem. So this is how you can show. Another way of showing it. Now two antennas are placed like this. Now let's just say this is having current I naught cos omega t. This is having I naught cos omega t, and this is having some current I naught cos omega t plus alpha I am taking. Okay, this is having some phase of alpha. So how will I show it? At D1 distance and at D2 distance. At D1 distance another antenna, at D2 distance another antenna. So at D1 distance, this is the antenna, because this is lying like this. This is lying along y-axis. So that's why I have made it like this. And this is also lying like this. So this is the other way of showing it. Okay. How much current flowing here? I naught current. And how much current is flowing here? I naught e to the power j alpha I can show. Okay. The phase is e to the power j alpha. Or sometimes I can show it like this as well. I naught and the phase is alpha. So you would be able to understand what I mean to say. This is having magnitude of I naught, this is having magnitude of I naught, and it is having a phase of alpha. Now let's change the magnitude as well. This is having I naught, this is having a magnitude 2 I naught. So here what I'm going to write? 2 I naught e to the power j alpha, 2 I naught e to the power, 2 I naught angle of alpha. Any way I can write down. Is that clear to you? Well and good. Let's understand some mathematics. Okay. We will come back to everything. We will come back, like what is our target now? Like there will be two antennas will be placed like this, and at a random point P, we will find out the electric field. This is our target, because if we know the electric field, then we know the P average, then we know the P radiated. So our target is to find the electric field, and then our target will be at what value of theta this electric field will be maximum or minimum. At what distance, like how much far we need to put them so that we get the maximum electric field. So these kind of questions can be asked in the examination. So that is a very, very simple process. So eventually our target is to find the angle of theta, or to find the distance at which this electric field is maximum. So at which distance or at what angle we are going to get our maximum power, that would be our target. So certainly we are going to come to that particular part, But let's understand some basic mathematics. So basic mathematics we are going to understand. So here there are 3 points A, B and C, and then there is a point P which is near to ABC only. This is not very far. Usually when we study antenna, if you remember, I told you that your R should be greater than lambda by 6, and if R is greater than lambda by 6, then we consider it as a far field. But this R is not too far. This R is not too far. This point P is very near to ABC. So now you just let me know one thing. What you will let me know? If I call this distance as R1, this distance as R, and this distance as R2. So can you let me know the relation? R2 will be greater than R, will be greater than R1. Say yes or no, right? If I call this angle as theta1, this angle as theta, and this angle as theta2, all these angles will be equal? Certainly not. What I mean to say is that theta1 will not be equals to theta, will not be equals to theta2. When they would have been equal? If the lines were parallel. If the lines were parallel like this, if the lines were parallel like this, these were the points, let's just say these were the points, and from here I take the angle. From here I take the angle. So this is theta1, this is theta, and this is theta2. If the lines were parallel, then the angle would have been same. But they are not parallel, so angle would be different. In the diagram it feels like that the angle are same. No, this is just the diagram. If you keep this point here, let's just say here, then you will realize that the angle are different, right? If the lines are parallel, then only angle would be same. Array, why I am writing equal here? This is also not equal. No angle is equal. So for near field, this is the thing we are getting. Now a very simple mathematics question is there. You need to find the R2 in terms of R1. What you need to find? You need to find length R2 in terms of R1. So what is the way of it? That from the shorter line, you will draw perpendicular on the longer line. From the shorter line, you will draw perpendicular on the longer line. So from one perpendicular I can draw from here, one perpendicular I can draw from here. So now you are just getting the projection of this smaller line on the longer line. Are you getting this point? Again I am repeating. What did I do? I took the projection. Now you are saying, sir, this is very simple mathematics problem. Why are you wasting your time here? You will realize why I am wasting the time. Like, since you have been studying right from the beginning, then you would be accepting that, then you would be knowing the thing that what we do, why we solve mathematics, because it will be used somewhere in our analysis. So from this particular line, I am drawing two perpendicular, and now I am getting the projection of this line 1.3 R1 line on the longer line. So that means I get to know that this my length is 1.3 R1. So now I can write down my R2, that is R1, which is the extra part. This is the common part 1.3 R1, and this is the extra part. Okay, so this will be the answer, which is 2.5 R1. This was simple mathematics problem, like class 6th guy can also solve this, but I will use it somewhere. Then you will realize that why I spent this time here, and this analysis I will be also using. Now I will take this point P far away. If I take this point P very far away, then you let me know one thing: all these three lines will be parallel or not? Try visualizing it. If this point P is very far, just hold this point P and pull it. Let's just say these are ropes, okay? These are some strings. These three are the strings which is connected to point P. And now you do not, like, these ABC point will be there at their own place only. ABC point are there at their own place only. Now you pull this point P. You pull this point P to very far place. Then what will happen? Eventually these strings will become parallel, no? Are you able to visualize this thing? A point P is very far away, and you need to reach to the point P from A, B and C. Then these strings will be parallel only. These lines will be parallel only. Like, almost these lines will become parallel. Now I am saying that what I am gonna do, again I am gonna do the same thing. I am gonna make a perpendicular line passing through them. Okay. Now if I call this angle as theta1, this angle as theta, and this angle as theta2. So can I write down here that my theta1 is equals to theta is equals to theta2, right? Because these lines are parallel now. If the point P is far away, then these lines will become parallel. And if these lines are parallel, then theta1 is equals to theta is equals to theta2, right? Now one more thing. If I call this distance as R1, this distance as R, and this distance as R2, are these three distances equal? You will say they are almost equal, but not completely equal. What I mean to say is that one guy is walking from here to infinity, One guy is working from here to infinity, and other guy is working from here to infinity. So this guy is working more, no? This guy is certainly working more. Let's just say I need to go to this point. One guy is standing here, one guy is standing here. He needs to walk only this much distance, but this guy needs to walk this much distance. The guy who is downward, he needs to walk more, no? So certainly here, which relation I can tell? That R2 is greater than R is greater than R1. Say yes or no? They are slightly greater, but certainly they are greater. R2 is slightly greater than R, and it is slightly greater than R1. Because what is this distance? This distance is infinity, because point P is far away. What is this distance? This is also infinity. And what is this distance? This is also infinity. That means this is also very, very large. But certainly there is small difference, no? Let us say one guy is here, one guy is here, and I need to walk to this point. So this guy will walk this much, but this guy will walk slightly more. Now, how will you find that slightly more distance? How will you find that slightly more distance? Now, between A and B, I call the separation is D1. And between B and C, the separation is D2. So can you find out the slightly more distance? What you will do? If there are two parallel lines, what you do there? You will draw perpendicular from the shorter line to the longer line. So this is the shorter line. From the shorter line, I will draw a perpendicular to the longer line. So this is the longer line, and I am drawing the perpendicular. So this is the perpendicular that I have drawn. This is the perpendicular that I have drawn. So I need to show the angle again. Right? Now this portion and this portion both are equal. What I mean to say is that from here till infinity, the distance is R1. From this particular point to infinity, the distance is R1. Because this is the projection I have taken. Now this is the extra point. Which is the extra point? This is the extra point. And what will be this point? If this distance is D1, so what will be this distance? D1 cos theta. Say yes or no. Right? If this is your R1 distance complete, so what will be this distance? This is your right angle triangle. 90-degree angle, theta angle. So D1 cos theta. So how much is this distance? D1 cos theta. Okay. So here what I can write down is, so this is why I took this question. From two parallel lines, if you draw a perpendicular, that means you are taking the projection of the smaller line on the longer line. Whatever the portion that is left, that will be your extra distance. So certainly I can write down one thing. What is that? That your R1 plus D1 cos theta is equals to R. Why I have like this angle is theta? Okay, yeah. So from here can I find out my R value? Sorry, can I find out my R1 value? So R1 is R minus D1 cos theta. Okay. This is your R1. Now let's remove this one because it will make the diagram more complex. Now what I am doing? Now from here also I can draw a perpendicular because I know that my R2 is larger. My R2 is larger than R1. So what I am doing? Again I am drawing a perpendicular. So what will be this much distance? This is C. What will be this much distance? This much distance will be D2 cos theta 2. Right? This much distance will be D2 cos theta 2. So D2 cos theta 2 plus R2 is equals to R. Sorry. This distance and this distance is equals to R only, no? From the smaller line, you are drawing the perpendicular on the longer line. So this distance is R. So R plus D2 cos theta is equals to R2. So what is the value of R2? Value of R2 is R plus D2 cos theta. How this is D2 cos theta? I hope you are knowing this thing. If you have studied EMFT, then at least you know how to take the projection. D2 cos theta. This is D2 cos theta and this is your R. This much distance is your R. So R plus D2 cos theta is equals to R2. Now if you need to find the relation between, R1 and R2, that also you can find, but this is not our matter of concern here. We don't need to find the relation between R2 and R. If you want to find it out, then you can find out, but this is not our matter of concern as of now. Is that clear to you? And why I did not write cos theta 2 here? Why I did not write cos theta 2? Ideally, I should have written cos theta 2, no? But here, theta 2 is equals to theta 1 only. So what it will be equals to? Cos theta. So here I have written cos theta. Is that clear? Is this geometry clear to you? This geometry is clear. This relation is clear. Now we need to use all these expressions in our antenna theory. When we study about antenna array, all these expressions will be used. So there what I am gonna do is that I am gonna take R1 nearly equals to R nearly equals to R2, because this is far field, no? They are nearly equal. This R1 is nearly equals to R, that is nearly equals to R2. What I mean to say is that, let's just say R1 is 1000. R1 is the smallest one, and this is 1200, this is 1100, let's just say, and this is 1200, or this is also very far. Let's just say this is 1001 and this is 1002. So this is your R, this is your R1, this is your R, and this is your R2. This is the relation, that this is the greatest one than this. So all are nearly equal, right? So what I'm gonna take is that this relation I'm gonna take, that my R1 is nearly equals to R is nearly equals to R2. But if I multiply this with a particular factor, let's just say I multiply it with beta, I don't know what is the value of beta. Are you getting this point? If I multiply all these things with a particular factor, then this factor can change, no? What I mean to say is that this factor can change this relation. The relation that this will be smaller than this one, this will be smaller than this one, that will always hold true. But if I am saying that my R1, if I am saying that my R2 is greater than R is greater than R1, then if I multiply with beta, so for this particular analysis, I said that my R2 is nearly equals to R is nearly equals to R1. But when I multiply with beta, then I cannot say that beta R2 is nearly equals to beta R is nearly equals to beta R1. At that time I cannot say, because I have multiplied with another factor. So that factor I need to take into action. Are you getting this point? Right? So if I have multiplied them with beta, at that time I cannot say that both are nearly equal. At that time what I will say, here I cannot say that if I multiply beta everywhere, so I cannot say that beta R2 will be nearly equals to beta R will be nearly equals to beta R1. This relation I am not gonna use. Okay, so this nearly equation, this nearly equality I am not gonna use. This equality I am gonna use, but this will not be used. Are you getting this point? So whenever you are multiplying the distance with the particular factor, at that time you cannot say that all are nearly equal. Here they are certainly nearly equal. Okay, but if you multiply with beta, then we cannot say they are nearly equal. Like 1000 is, you can say like it is nearly equal. All three are nearly equal. If you are talking about very large distance, if I call this as 1000 kilometer, this is 1100 kilometer and this is 1200 kilometer. But if I multiply with beta, let's just say my beta is 1 upon 1000. So now what this will become? 1. This guy will become 1.1 and this guy will become 1.2. So now they are not near. 1 is far away from 1.1 and 1.1 is far away from 1.2. But now in the matter of distance they are equal only. But if you multiply with beta, then you cannot say that they are nearly equal. Are you getting this point? So when we do the analysis, at that time you will not say that beta R2 is nearly equals to beta R1 is nearly equals to beta R2. Are you getting this point? So now we are going to start our analysis. Okay, but before that, one more mathematics. After that we can start our analysis. Okay, just one simple mathematics we are going to see, because after that we can completely study our antenna array. Till this point we are just seeing the mathematics and all the basic things which is required for the derivation. Then we can start our antenna array completely. So now again, this basic mathematics we have already seen in when we study the standing wave pattern for EM wave. There also we studied it. When we study the standing wave pattern for transmission line, there also we studied this mathematics. So what you need to find? You need to find the maximum value of phase difference for maxima and minima. Okay, so this is the number. So what we used to do? We used to take e to the power j theta 1 common, 1 plus e to the power j theta 2 minus theta 1 it would be, right? So this is the phase difference. theta 1 minus theta 2 or theta 2 minus theta 1. If you talk about difference, then you can take any of the phase difference, theta 1 minus theta 2 or theta 2 minus theta 1. Then I know that magnitude of this will be 1 only. And what about this guy? So for maxima and minima. So for maxima, what you need to do? For maxima, theta 2 minus theta 1 should be equals to what? 2n pi. For minima, theta 2, for minima, what will be the scene is that theta 2 minus theta 1 will be equals to 2n plus 1 pi. I hope you remember this thing, because if you put 2n pi, that means it will be cos 0. Cos 0 is 1. So 1 plus 1, 2. What will be the minimum maxima value? 2. And what will be the minimum value? What is the minimum value of e to the power j theta? That is minus 1. So if you put 2n plus 1 pi, so cos pi is minus 1. 1 minus 1, 0. So this is the condition for minima. And what about the condition for half power? For half power. Half power means, let's just say this is the expression of electric field. So half power means you need the magnitude to be E naught by root 2. If this is your E naught, what is the maximum value? E naught. Half power means you need the magnitude to be 1 by root 2 of this. Are you getting this point? We will find the expression of electric field only. We are not going to find the relation of P average. But if I say half power, what should be coming into your mind? That you have found out the expression for electric field. That means now I need the maximum value divided by under root 2. So here what is the maximum value? That is 2 divided by under root 2. So what do you require? Under root 2. So when this expression will get under root 2? The expression is 1 plus e to the power j theta 2 minus theta 1. So the magnitude of this expression, you need that to be equals to under root 2. Why under root 2? You understood, no? Half power means the power should be half. And if this is the expression of electric field, that means maximum value is 2. So electric field should be 1 by under root 2 times of a maximum value. So that should be under root 2. So here maximum value is 2. So now I need the magnitude to be 1 by, now I need the magnitude to be under root 2. So when I can have under root 2 magnitude? When I can have under root 2 magnitude? When this is 1 and this becomes j, right? This becomes j. So what is 1 plus j? Magnitude of 1 plus j is under root 2. So when this e to the power j theta 2 minus theta 1 becomes j, at that time our job is done. Are you getting this point or not? A very, very important point. For half power, you need this magnitude, you need this expression to be j, because 1 plus j is equals to under root 2. So if I need this expression to be j, what is this expression? Cos theta 2 minus theta 1 plus j sin theta 2 minus theta 1. That means you need this guy to be 0 and this guy to be 1. And when this guy can be 1? At 90 degree. So theta 2 minus theta 1 you need 90 degree. Say yes or no? Are you understanding this point or not? At half power you need this point to be 90 degree. 90 degree plus 2 pi. That means pi by 2 plus 2n pi. This is what you require. Because after 2n pi it will keep on repeating, no? But when we talk about power, we take the magnitude. When we talk about the power, we take the magnitude, because eventually if you talk about the power, what is going to happen? E naught square by 2. If at half power you are getting e by under root 2 magnitude, but if you talk about the power, what it would be? E naught square by 2. So here for half power, theta 2 minus theta 1 should be the odd multiple of pi by 2. Should be the odd multiple of pi by 2. Say yes or no? Did you understand this point? That for half power, what I will require? That my phase difference should be the odd multiple of pi by 2. And n value can be from anywhere. It could be from n value starting from 0, plus minus 1, plus minus 2, and so on. So did you understand this point? For half power, what we are doing? For half power, we need the magnitude to be maximum magnitude divided by under root 2. So that means I need my magnitude to be under root 2. Again, I am writing down all the things. Again, I am explaining this point. Again, let me explain this point. If you have understood, then you can skip this part. You write down all these things for this particular expression. But if you did not understand, then I am explaining it again. What I need to do is that, what is my phase difference? Theta 2 minus theta 1. What is the maximum value? 2. I need half power. That means electric field expression should be under root 2 times of that. So I need my expression to be equals to under root 2. So what I am getting? 1 plus something. If this is j, so what is the magnitude of 1 plus j? That is under root 2. So I need this to be j. And what is this expression? Cos theta plus j sin theta. Right? If this is 0 and this is 1, my job is done. You need this to be j. It could be minus j as well, no? If it is minus j, then also your magnitude is under root 2. And if it is plus j, then also your magnitude is under root 2. You need your magnitude to be under root 2. This is your task. So whether it is plus j, whether it is minus j, your job is done. So this needs to be 0 and this needs to be plus minus 1. And when they are plus minus 1, sin theta is plus 1 at pi by 2, and then minus 1 at 3 pi by 2, then 5 pi by 2, 7 pi by 2. In that manner it will keep on going. That means what is the value? That it should be odd multiple of pi by 2. If you put n equals to 0, pi by 2. If you put n equals to 1, 3 pi by 2. If you put n equals to 2, 4. If you put n equals to 2, that would be 5 pi by 2. And certainly plus minus sign is also there. So n value you can put anything, 0 plus minus 1 plus minus 2. If you put minus 1, what you are getting? Minus pi by 2. If you are putting minus 2, what you are getting? Minus 3 pi by 2. So in that manner. Okay, so that's why you need to keep these things in mind. That if you see expression like this, if you see any expression like this, then you should be able to tell where will be maxima, where will be minima. So now if you see expression like this, what do? Here when we study about antennas, so at that time I am not gonna bring this e to the power j theta outward. What I am gonna do is that I will directly calculate the phase difference and then I will write down these things. Right? When we study about our antennas, I am not gonna take this outward. Like when we were studying about our standing wave pattern. So at that time I used to take this outward, then I used to write down 1 plus 2 e to the power j theta 2 minus theta 1. This is how I used to write down, and then from here onwards we used to derive the things that for maxima, minima, what all things were there. So at that time we were analyzing only maxima and minima. Right? Here can I call minima as null? Because we are going to study about antennas, and in antenna what do we have? Null. That means 0 power. 0 power point is known as null. So for antennas I can call it null. So for maxima what will be the condition? For maxima the condition would be that theta 2 minus theta 1 should be equals to 2n pi. For nulls, what would be the condition? That theta 2 minus theta 1 should be the odd multiple of pi. Here it should be even multiple, they should be odd multiple of pi. And for half power, what should be the condition? That theta 2 minus theta 1 should be odd multiple of pi by 2. So very important point, like your all the questions are based on this slide only. All the questions will be based on this slide only. So that is, this slide is very important for you, and I hope you are understanding the meaning of this complete slide. If you have already studied our standing wave pattern, then you would be already knowing about it. Is that clear to you or not? So you need to keep these things in mind, that for maxima what is the phase difference I need to put, for nulls what is the phase difference I need to put. Why null? Because here you are getting the magnitude to be 0 only. 1 minus 1 is 0, 1 plus 1 is maximum 2, and 1 plus j is half power. So you need to keep this in mind. Right? Let's start studying about antenna arrays now. So first we are going to study about 2 element antenna array. So there are 2 antennas which are placed on z axis. Antennas are placed on z axis, right? And they are placed along y axis. Are you getting this point? What did I say? Antennas are placed on z axis. Antennas are placed on z axis, but they are placed along y axis. This is my z axis. Antennas are placed along y axis, but they are placed on z axis, right? So 2 antennas are there, and this point P is at far point. This point P is far away. So what will be this angle? If I call this as theta, this angle also I can call theta. So there are 2 antennas. Just for the analysis purpose, I will take another point from the origin as well. Here there is no antenna. Only two antennas are there. This is first antenna. This is the second antenna. This is also making angle of theta with z axis. This is also making angle of theta with z axis. And I know that all these angles will be equal. Theta 1 will be equal to theta 2 will be equal to theta 3. That I know. This point P is very far away. This point P is far field. So this point P is at distance r1 from this antenna. It is at distance r from the origin, and it is at distance r2 from this antenna. Are you getting this point? This distance between this antenna and point P is r1. Distance between this antenna and point P is r2. And from the origin, if I talk about spherical coordinate system, so in spherical coordinate system, what we used to do? This is our z axis. This is point P. So we used to calculate the distance from origin. We used to call this distance as r, and then we used to say that from z axis the angle is theta. If I take the projection, then this angle will be phi. So this is what we used to say. Same thing we are doing. The point P is at far field. We are saying that all these antennas, these two antennas are making the angle of theta with z axis, because since it is at far field, lines are parallel, angle would be same, but distance would be different, right? Now this distance is d1 and this distance is d2. So if I say what is the spacing between the antenna, what is the spacing between the antennas? Spacing between the antennas, that is d1 plus d2, right? It is not d1, it is neither d2, it is d1 plus d2. The distance between two antenna is d1 plus d2. From the origin, this is d1 upward, from the origin, this is d2 downward, right? So this is the scene. Now I need to find the electric field potential at point P. So one electric field will be coming because of this antenna, and another electric field will be coming because of this antenna. So first write down because of this antenna what that would be. So that would be electric field potential at point P. So that would be ideal. Yeah, current I forgot to write down. So current here I am going to write down the current as I naught e to the power j alpha 1, and here I am writing the current to be I naught e to the power j alpha 2, and magnitude I am writing as B. Let's just say this is having a current of I naught, so this is having a peak current of B I naught. If this is having a phase of alpha 1, this is having a phase of alpha 2. What I mean to say is that this current expression could be something like this, and this current expression could be something like this. So with respect to the origin, so with respect to the zero phase, this is having a phase of pi by 3, and with respect to the zero phase, this is having a phase of pi by 6. This is what I am writing. Are you getting this point? And if this is having a magnitude of I naught, this is having a magnitude of 2 I naught. So I naught e to the power j alpha 1, B I naught e to the power j alpha 2. Current expression is clear? So here what I am going to write. So that would be, here the current is, what is the current? Current is I naught e to the power j alpha 1. I will write down this expression as well. E to the power j alpha 1 also I will write down. What we used to write down? Let us say this is Hertzian dipole. So for Hertzian dipole, what is the electric field? I dl sin theta upon 4 pi r j beta e to the power minus j beta r a r cap. Do you remember from where this j beta r came? From I naught cos omega t minus beta. From here this e to the power minus j beta r came. Now the expression is this is having a phase of alpha 1 as well. This is having a phase of alpha 1 as well. So if you take the phasor of this, what will happen? E to the power minus j beta r e to the power j alpha 1. So that's why I'm going to write down this j alpha 1 as well, right? If you remember the derivation from where it all came because of this expression. So at that time there was no alpha 1, but now we are having alpha 1. So this alpha 1 also I will write down. So what is the expression? I dl sin theta. I dl sin theta. What is the angle? Angle is that is the angle between the arms of antenna and AR cap. Arms of antenna and AR cap. What is that angle? 90 minus theta. So this angle is 90 minus theta. So here what I am going to put? Sin 90 minus theta. I dl sin theta upon 4 pi r. Just a second. I dl sin theta upon 4 pi r. And this is the phasor form we are writing. So EPS. Only phasor form we are writing, no time domain form we are not writing. So ideal sin theta upon 4 pi r e to the power minus j beta r. Here what I am going to write down, j beta r or r1, j beta r1. Here also I am going to write down r1 only. Here also I am going to write down r1 only. Say yes or no? Because from this particular antenna, the distance is r1. And when I write down for this one, I will write down r2 there. So is this expression clear? And here what I am going to write down ar1 cap. Is this expression clear to you or not? Say yes or no. Right? This is clear. Now let's write down because of the second one. So what is the current here? Current here is, here I forgot to write down j beta. Really sorry, I forgot j beta here. Ideal sin theta, j beta. J beta I forgot, no? So j beta expression also comes. Now for the second one, what it would be? The current is beta I naught. The current is beta I naught a to the power. This is not beta, this is b. So beta, so b I naught a to the power j alpha 2 dl. Same angle here also will come, no? Between the arms of antenna and AR gap. That would be 90 minus theta. So same angle here also is coming. Sine 90 degree minus theta divided by 4 pi r. B I naught e to the power j alpha 2 ideal sine 90 minus theta upon 4 pi. What is the distance here? R2 e to the power minus j beta R2 into j beta and here a R2 cap. Now you let me know one thing. R1 is nearly equals to R is nearly equals to R2. Say yes or no. So can I write down AR1 cap is nearly equals to AR cap is nearly equals to AR2 cap, right? But what did I say? That beta R1 is not nearly equals to beta R is not nearly equals to beta R2. So this beta R1 I am not gonna change. This beta R2 I am not gonna change. So what is your R1? R1 is R minus D1 cos theta. Say yes or no. R1 is R minus D1 cos theta. And what is your R2? R2 is R plus D2 cos theta. This is D2. So R2 is R plus D2 cos theta. Say yes or no. So this I am going to use and this I am going to use. I am going to put that in this expression. So what I am getting now? I naught e to the power j alpha 1 dl cos theta upon 4 pi r. Because R1 I can put as R. E to the power minus j beta R1 is R d1 cos theta into j beta AR cap. AR1 cap as AR cap. But this I am not gonna change. Plus B I naught e to the power j alpha 2 I naught dl cos theta divided by 4 pi r e to the power minus j beta r plus d2 cos theta into j beta AR cap. Now what you can take common? You can take common as I naught dl cos theta upon 4 pi r e to the power minus j beta r. How I am taking e to the power minus j beta r common? You see this expression. From here e to the power minus j beta r is coming common into j beta AR cap. Inside what is left? Here e to the power j alpha and here what is left? E to the power j beta d1 cos theta. You are getting this point, right? E to the power minus j beta minus d1 cos theta. So e to the power j beta d1 cos theta plus here I naught was as it is, but here b is there into b e to the power j alpha 2 plus e to the power minus j beta d2 cos theta. So this is the expression that you are getting, right? Ideal cos theta upon 4 pi r e to the power minus j beta r into j beta ar cap e to the power j alpha 1 e to the power j beta d1 cos theta plus b e to the power j alpha 2 e to the power minus j beta 2 e to the power minus j beta d2 cos theta, right? So now let's copy this and let's write down this expression again. Certainly in the examination you do not need to derive it. I will tell you a shortcut method that how you will be writing down in the examination. So in the examination you don't need to derive it. Okay. Now can you look at this expression? What is this? If I had put an antenna here, I am putting an imaginary antenna here. I am putting an imaginary antenna at the origin. If I put an imaginary antenna at the origin, just wait a second. Yeah, so what I was saying, if I put an imaginary antenna at the origin, this antenna is not actually there. This is the imaginary antenna. If I put that at origin, then at distance r from the origin at far field point P, what will be the electric field? That would have been I naught. I am assuming the current is I naught. I am assuming there is no phase. So a simple I naught current, if I put an antenna having I naught current in the same orientation, these antennas were put like this. So this is how I am putting it. At the origin, if I put that, and at distance r, if I ask you to write down the electric field, then what you would be writing down? I naught dl cos theta. Why cos theta? Because usually we write sin theta, but the angle is 90 minus theta. So what I would be writing down? I dl cos theta upon 4 pi r e to the power minus j beta r into j beta into ar cap. This is what I would be writing down. So are we getting the same thing there? So this was imaginary antenna that I am gonna remove. So we are getting the same thing here. Ideal cos theta upon 4 pi r e to the power minus j beta r into j beta ar cap. So what I will write? This is the electric field due to single element at origin. Electric field due to single element at origin. Electric field due to single element at origin having current I naught and zero phase. So this I am gonna write down as electric field due to single element at origin. Single element at origin. So this is your this. And this is known as array factor. What this is known as? This is known as array factor. Okay. From now onwards, I will be writing this down as AF, array factor. So when there were two antennas, because of these two antennas, when I wrote down my electric field at point P, I got to know that it is becoming equivalent to considering a single element at the origin, or you can say considering single antenna at the origin into some array factor. So this is very easy to write down. Now I will tell you how to write down this array factor. So now let's see the shortcut method. This was the derivation. We have done the derivation. You are happy that this is how the expression came. But now I will tell you the method that if you see any kind of structure, if you see any kind of orientation, then how will you write down the expression of antenna array and the complete expression at point P? So how will you write it down? So in the mind, what you are going to think, okay, here they have given I naught current, here they have given B I naught current, this has the phase of alpha 1, here this has the phase of alpha 2. So I naught I can see common. So imaginary, here this current is I naught, this current is B I naught. So I naught I can see common. So here what I'm gonna assume? I'm gonna assume a imaginary antenna at the origin. This will be the first assumption. And what I will do? I naught is common. So this is having current I naught. This is having phase alpha 1. This is having phase alpha 2. So here I will assume phase to be 0. Then I can say that this is alpha 1 ahead and this is alpha 2 ahead, right? This is having a phase of 0, this is having alpha 1 phase and this is having alpha 2 phase. Say yes or no. So this an imaginary antenna I am gonna assume here. So first I am gonna write down my ESO. That would be I naught dl cos theta. Why cos theta? Because this angle will be 90 minus theta upon 4 pi r really sorry guys, I cannot control it, right? So that's why, like, I know you are getting disturbed because of this. Again I need to post the video. Yeah, welcome back guys, really sorry for the interruption. So we were writing electric field due to this imaginary antenna at the origin. Imaginary antenna at the origin. Imaginary antenna at origin. So this is having I naught current and a phase of 0 degree, right? Camera ko kya ho gaya yaar? Yeah, so you need to write down that IDL cos theta upon 4 pi r into j beta e to the power minus j beta r AR cap. So this will be the electric field component because of the single element. Now we need to write down array factor. So how will you write down array factor? So let's write down array factor now. So don't read these points, forget about these points. So what you are gonna do, first you will see that this current, now we are writing down array factor component because of this particular element. So now this current is leading by alpha 1 from the imaginary antenna. So now our reference is our imaginary antenna. Our reference is the imaginary antenna that is at the origin. So here what is the phase difference? That is alpha 1. So this is leading by alpha 1. So here I am gonna write down e to the power j alpha 1. Then again e to the power j beta. Now here I am gonna write down something. What that would be? So what I am gonna do is that from the origin to this antenna, from the origin I am calling this as antenna 1 and this as antenna 2. Okay, this is my antenna 1, this is my antenna 2. So from the origin towards antenna 1 I will draw a vector. From the origin towards antenna 1 I will draw a vector. That vector I am calling as d1 vector. This vector I am calling as d1 vector. So what is this d1 vector? This d1 vector is having a distance of d1 and the direction of az gap, because it is in the direction of az, right? And from the origin towards the antenna 2 as well I will draw a vector. Like vector could be anything. This is your d2 vector. Now what is your d2 vector? D2 vector is d2 and having a direction of minus az gap, right? So what I have drawn, this d1 vector I have drawn. This is coming because of antenna 1. So here what I am going to write down, d1 vector dot AR gap. Which AR gap? What is AR gap? This is your AR gap. d1 vector dot AR gap, right? And now this has been done. This is because of antenna 1. Now the job of antenna 2 will come into action. So e to the power j. At the origin what is the phase? 0. Here what is the phase? Alpha 2. So e to the power j alpha 2. E to the power j beta. Now coming to this, again I am writing down this vector. So this angle was theta. So from the, and this distance was d2. So from the origin I will make a vector. That is my d2 vector, and that d2 vector is minus d2 az gap. So now here what I am going to write down, j d2 dot AR. From the origin towards the antenna. Where is my vector? From the origin towards the antenna. From the origin towards the antenna. Now d2 dot AR gap. What will be d1 dot AR gap? Can you tell me? d1 dot AR gap. Look, the first way could be like this, that d1 az dot AR. Because what is my d1 vector? D1 vector is d1 az gap. And what is ar cap? Ar cap is ar cap only. What is this value? Az dot ar. If you remember, on the first slide only, on the very first slide, az dot ar is cos theta. So az dot ar is cos theta. So answer would be d1 cos theta. And if you write down d2 dot ar cap, so what is your d2? D2 is d2 minus az gap dot ar gap. So what will be the answer? Minus d2 cos theta. But in the examination I will prefer geometry, because I can see this d1 vector here, I can see this ar vector here. What is the angle between both of them? Cos theta. So I can directly write down d1 dot ar, that is d1 cos theta. In the examination I am not gonna write down this step. Are you getting this point? I am gonna ignore this step in the examination. What I will see, from the origin towards the antenna, d1 distance is there, and if I need to take the dot product, then this is the direction and this is the direction. Between them, what is the angle? Cos theta. From the origin towards the antenna, from the origin towards the antenna, d2. Now this vector and this vector, which vectors? This vector and this vector. How much angle they are having? They are having the angle of 180 minus theta. The angle is 180 degree minus theta. So d2 cos 180 minus theta. And what is cos 180 minus theta? Minus cos theta. So minus d2 cos theta. So from the geometry also you can solve, or you can write down the expression as well. Whatever that is more convenient to you, that you can solve. But in the examination, certainly if the question is coming from antenna, whether it is from antenna or antenna array, my first task will be to make the diagram. And if I am making the diagram, then my job is done. Right? So this is how I can write down my this vector as well, d1 dot ar, d2 dot ar. So here if I solve this, what I am getting, my array factor would be e to the power j alpha 1 e to the power j beta d1 cos theta plus e to the power j alpha 2 e to the power j beta d2 cos theta. Beta d2 cos theta, but minus sign is there, because this is minus sign is there, no, here d2 dot ar is minus d2 cos theta, so minus sign is there. So this is your array factor. Now if I need to write down the complete expression of electric field at point P, and we are writing the phasor form, so what that would be? Imaginary antenna at the origin having the current of I naught and having the phase of 0. So it will give you ideal sin theta, but angle is 90 minus theta, so that's why cos theta upon 4 pi r e to the power minus j beta r into j beta into ar cap e to the power j, phase is alpha 1 e to the power j beta. Now from the origin towards the antenna, d1 ar cap, so d1 cos theta plus e to the power j alpha 2 e to the power j from the origin towards the antenna, d2, but angle is 180 minus theta, so that would be cos theta but negative sign. There you go. Within one line only you have wrote down the complete expression. For this expression we spent 30 minutes just to get this expression, but in the examination you are going to spend only 30 seconds to write down this particular expression. To understand it we took 30 minutes, but in the examination this will be a job of 30 seconds, because this derivation you are not going to do. The method that I told you, using that method you can write down the expression of electric field of any orientation of any number of antenna, like anywhere you can do the analysis. Are you getting this point? And if I ask you the phase difference here, so what will be the phase difference here? What will be the phase difference here? So this is the phase, that is alpha 1 plus beta d1 cos theta. So better way of writing it down would be alpha 1 plus beta d1 cos theta. And here the better way would be alpha 2 minus beta d2 cos theta. Right? This could be the better way of writing down. And if I ask you the phase difference, then you can subtract this from this one, or you can subtract this from this one. So now are you able to relate the points why we spend time in mathematics? Because here what this is becoming, e to the power j theta 1 plus e to the power j theta 2. Again there is a small blunder from my side. Here the current was I naught, so nothing came, but here the current is B I naught. So here B will also come, no? Here B will also come. Here B will also come. This current was B I naught. This current was I naught. These two current were same. But now this current was B I naught here. This current was B I naught. So that more expression, that B expression will also come here. So this B expression will also come here. Okay. So that was a small blunder. Here also you can see B is there. So that B will also come because the current magnitude were different. So that's it. Your chapter is done. Now in the examination, what they will ask? That maxima where you will get. So for maxima, what you will do? You will calculate this phase difference, theta 2 minus theta 1, and then you will put it equals to 2n pi, 2n plus 1 pi, and in that manner you are going to proceed. Usually what student does is that they mug up some formula. That they mug up this formula. The phase difference will be alpha plus beta d cos theta. If you have already studied, then you would have mugged up this formula. But that is for a very specific case. For a very specific case, you have derived this formula. But in the examination, they will never ask you the standard cases. They will make random diagram, and in the random diagram, they will ask you to do the analysis. Like this kind of questions they will ask in the examination. It's a very random diagram. So I will tell you how to solve these kind of problems. But believe me, you know every single point about it. So no formula mug up, nothing. No formula, zero formula we are going to mug up in antenna array. We will just solve by the method. What is the method? No matter how many antennas are there, always assume a single element at the origin. Having current I naught, having zero phase, write down the electric field. That is the first job you have done. The second job is to write the array factor, and that method I have told you. Now let's come to this point. Two half-wave dipole antenna. Yeah, this expression we find out for Hertzian dipole. We assume this is our Hertzian dipole, but it could be anything. It would be half-wave dipole, it would be full-wave dipole, it could be anything. Okay, so do not worry about that it is applicable for half-wave dipole only or for everyone. It is applicable for everyone, for any kind of antenna. So let me take a pause, guys, again. Yeah, so let's start this question now. Again, sorry for the interruption. I cannot help it, right? But I hope in the conceptual part there is no lag, nothing like that, right? You are understanding the conceptual part at least. I need to pause the video again and again because of the, like, my health is just draining again and again. It is just getting worse. It is not even improving. So anyway, I need to pause, right? But yeah, I hope you are not getting frustrated. I hope you are getting the concept in a good manner. So that is the more important part, I guess, rather than these pose and all. So let's start this question. Two half-wave dipole antenna are placed as shown in the figure, excited with the sinusoid varying element of frequency 3 megahertz. So they have given the, like, omega value they have given, f value they have given. Like if the current source is cos omega t plus alpha 1, so this omega value they have given, right? Although I don't think it will be used somewhere, or it might be used. So f value they have given, that is 3 megahertz. That is same for both of them. Having a phase shift of pi by 2. The element at the origin leads in phase. That means what they mean to say is that if I assume that this is having a current of I naught having 0° angle, then this will have a current of I naught having minus pi by 2 angle. Say yes or no. This antenna will have a current having a phase of minus pi by 2 angle. Right? Because this is leading. At the origin, the element is leading. So this is having a phase of 0° and this is having a phase of minus pi by 2, right? The maximum radiated E field at point P. Just once again. Yeah. Here I did not write down neta. In all the expression I did not write down neta. So in all the expression neta will come. Just it clicked to me. Here neta will also come, no? Otherwise all these expression will be of a magnetic field. So in all the expressions neta will come. Yeah. So the maximum radiated E field at a point P in the xy planes occur at a azimuthal angle of 60°. So at azimuthal angle of 60°, you are getting the maximum radiated E field at point P. You need to find the distance d in meters between the antennas. Okay, so let's start solving the question. What we need to find? We need to find the radiated E field. Radiated E field. This is our target. So how I can write down my E field? So first I will write down the E field because of the imaginary antenna at the origin. So I need to assume an antenna at the origin, which is already there. But I will assume it from my side. What I am going to assume? At the origin I am having this antenna. At the origin I am having this antenna, which is having a current of I naught and a phase of 0°. And at a distance r, I need to write down at a distance r. This is the OP distance which I can call as r only. And this will be also nearly equals to r only, kind of r only. Because this is a far away. OP is very greater than D. So this point P, this point R is very far away. So this antenna I have assumed which is having I node current. So what I will write down? Ideal sin theta upon 4 pi r. Now what will be that theta? That theta is the angle between arms of antenna and AR cap. Angle between arms of antenna and AR cap. Now where is this vector? Where is this vector? This vector is in xy plane. What they are saying? Point P is in xy plane. This is in xy plane. If this is in xy plane, then what is the angle between this antenna and this guy? Angle between the arms of antenna and AR cap. What will be the angle? 90 degree. Say yes or no? Arm of antenna and AR cap. This is the scene. The point P is in xy plane and the antenna is along z axis. So antenna is here along z axis and point P is in xy plane. So the angle will be 90 degree. So cos 90, that would be 1. e to the power minus j beta r into j beta AR cap. Now I need to write down the array factor. So for array factor, first thing what I am going to do, I will see the location of both of the antennas. So this is here, another one is here, and my imaginary antenna is at origin. Now what I am going to do, I will treat this as antenna 1 and this as antenna 2. So first I will see the phase of current. So what I assumed? I assumed the phase to be 0 degree. Here the element 1 is having the phase of 0 degree only. So what I will write down here? E to the power j 0 degree phase. My imaginary antenna was having 0 degree phase and this element 1 is also having 0 degree phase. So here I have written e to the power j 0 degree. Then e to the power j beta. Now I will join my imaginary antenna from the origin towards the element 1. Now I will join my imaginary antenna which is at origin towards the element 1. So what is the distance between the element 1 and your imaginary antenna at the origin? Tell me. What is the distance? 0, no? Because element 1 is already at the origin, also your imaginary antenna is also at the origin only. So what is the distance there? The distance is 0. So into 0 plus e to the power j. Now this antenna is leading this current by minus pi by 2. Sorry, it is leading, or you can say it is lagging by pi by 2, or you can say leading by minus pi by 2. So e to the power minus j pi by 2 into e to the power j beta. Now there is an imaginary antenna at the origin. From my side there is an imaginary antenna at the origin. This is my origin. There is an imaginary antenna at the origin. Now from here at distance d, another antenna is there, that is antenna 2. This antenna is antenna 2. This is my imaginary antenna and this is your antenna 2. So what I am going to do, from the origin, from the imaginary antenna towards the antenna 2, from the imaginary antenna at the origin towards the antenna 2, I am going to assume a vector. And that vector will be this vector. This vector I am going to assume. That is my, what is this distance? D distance. So I can call this vector as dAx cap. And then, so here I am writing dAx cap dot AR cap. Where is my AR cap? This is my AR cap. Where is my AR cap? This is my AR cap. If I need to write down here, this is my AR cap. So here I can write down dot AR cap. What is your AX dot AR cap? AX dot AR cap, if you remember, that is sin theta cos phi. What is the value of theta here? On xy plane, what is the value of theta? Theta is pi by 2 degree only. From z axis on xy plane, what is the value of theta? Pi by 2. So sin pi by 2 is 1. And what is cos pi? Cos phi, sorry. Phi is the angle made from x axis, that is 60 degree. So cos 60 here. Cos 60. cos 60. So what you are getting? Half, right? Sin pi by 2 is 1, cos 60 is half. This is by doing the analysis Ax dot AR. But if you see the geometry, in the examination, if you are able to see the geometry, so this is your D1 vector. This is my D1 vector, or D vector you can say, and this is your AR. What is the angle between them? 60 degrees. So directly here you can write down beta D cos 60. Say yes or no. Either you can do this analysis that you write down D1 vector D Ax cap dot AR cap, and then you solve it by this, or you see the geometry only. No, 99% of the question will be solved by geometry. If any question is coming from spherical coordinate system, Cartesian coordinate system, cylindrical coordinate system, from any one, if the question is coming, your 99% chance is there that you will never have to apply these formulas, because they frame the question in a manner that those who are having a clear concept, they will be able to solve with the geometry only. Otherwise you can apply the formula as well, but here directly I can see the geometry, that is cos 60. So here it would be 1 by 2 only, right? And now there will be no minus sign. Why there is no minus sign? Because the angle is 60 degree. It is not 120 degree. If it was 120 degree, then cos 120 would be negative, but cos 60 is half only. Okay, so this is the expression we are getting. So if I write down only the array factor, so what is the array factor we are getting? So array factor is e to the power j 0 degree, that is 1 only. So I can write down this as 1, because e to the power j 0 degree, e to the power j degree 0 degree is 1, and e to the power j, this is also 0, so that would be also 1. So 1 plus e to the power minus j, e to the power minus j pi by 2, and e to the power j beta d by 2, right? So this is the array factor you are getting. Now what they are saying that if maximum radiated electric field, so now you need to get the maximum value of this expression. So what will be the magnitude of this expression? That magnitude will be I dl 4 pi r e to the power j beta r will have magnitude 1. J beta will have magnitude beta only. So this guy will not decide the maximum amplitude. Who will decide the maximum amplitude? They will decide the maximum amplitude. Because here what is variable? D is variable. Here D is variable to you. Basically D value you don't know. It is not variable, you have fixed it, but D value you don't know. So whenever they ask about maxima, minima or nulls, you always need to look at only array factor. Where you will look at? For maxima, minima, nulls, half power, where you will look at? Only array factor. So in the examination, if this question was coming, then I wouldn't even write down this expression, because they are asking me maximum electric field. If they are asking me the expression of electric field, then I would write down this expression. But if they are asking me the maximum electric field or minimum electric field, or they are asking me the half power, then I do not even need to look at this particular expression. I will only write down the array factor, and I know how to write down the array factor, right? Imaginary current element at the origin having 0 phase. This is having a phase of 0 with respect to that. This is having a distance of 0 with respect to that. This was having a phase of minus pi by 2 with respect to the element at origin, and e to the power j beta. Now I need to write down d1 dot ar cap. So what is my d1? From the origin towards the antenna, d ax cap dot ar cap. Ax dot ar, I can see what is the angle, cos 60, 1 by 2. Now what they need to find? Maxima. So for maxima, can you tell me what should be the condition? The condition should be that your beta d by 2 minus pi by 2 should be equals to 2n pi. Say yes or no. Because what is the phase difference here? What is your array factor? E to the power j 0 plus e to the power j beta d by 2 minus pi by 2. Say yes or no. So what is the phase difference? Phase difference is beta d by 2 minus pi by 2. So this is the phase difference. So what did I tell you? First calculate the phase difference. So I am writing that my phase difference phi, my phase difference phi is equals to beta d by 2 minus pi by 2, and for maxima it should be equals to 2n pi. For minima or for nulls it should be equals to 2n plus 1 pi, but for maxima it should be equals to 2n pi, right? Now n value could be from anything, plus minus, it could be anything, it could be plus minus 1, anything it could be. But what they are asking, the minimum value of d they are asking. The distance d in meters between the antenna is maximum radiated field in the They did not mention minimum value, but certainly you need to tell the minimum value only. Minimum value of D. What could be the minimum value of D? There are a lot of possible values of D with respect to n value, right? Are you getting this point? So if I solve this one, what I am getting, beta D is equals to 4n. This 2 goes here, 4n pi plus pi, 4n plus 1 pi. And what is your beta? Beta is 2 pi by lambda. 2 pi by lambda. So pi pi gets cancelled. What you are getting? 4n plus 1 by 2 into lambda. So what all you can put? N equals to 0 you can put. So if you put n equals to 0, what you are getting? Lambda by 2. So this is one of the possible answer. You can put n equals to 1 as well. So what you are getting? D equals to 5 lambda by 2. This is also one of the possible answer. If I put n equals to minus 1, then what you are getting? D equals to, if I put n equals to minus 1 here, minus 4 plus 1. So it would be minus 3 lambda by 2. So this is not possible. Okay. This is not possible. So here I need to put the positive value of n only, because if I put the negative, then I will be getting negative answer. So this is not possible. So here I will put that in box and I will tell you not possible. So basically your possible answer are lambda by 2, 5 lambda by 2 and in that manner. But we will always write down minimum distance. In the examination, we will always write down minimum distance. So this would be my answer. The distance should be equals to lambda by 2. Now what is lambda? Lambda is equals to C by F. So 3 into 10 to the power 8 divided by F. F is 3 into 10 to the power 6. So lambda is 100 meter. Lambda is 100 meter. Okay. This is your lambda. So what is the answer you are getting here? 100 by 2. So from here D is coming out to be 50 meter. Very easy question. Very easy question. Very straightforward. So it looks like a big question because I am spending a lot of time in explaining, but in the examination very quickly you will be able to write down this step, because phase difference will not be that difficult. First step will be this one, then next step will be this one, and from there you can solve it very easily. There only you will realize that if they are asking the distance, that means I need to tell the minimum distance. So D equals to 0 I will put, and then from there I will get the D equals to lambda by 2. Lambda value I can quickly calculate. The answer will be 50. Say yes or no. Now someone is having the doubt, sir, that sir, how did you take the phase difference to be beta D by 2 minus pi by 2? Can I take the phase difference to be, sir, 0 minus beta D by 2 minus pi by 2? Then the phase difference will be, sir, pi by 2 minus beta D by 2. Yes, you can take this phase difference as well. But there n value negative you need to put. In this case, if I put the value of n to be negative, I go to know that this is not my acceptable answer. Now in this case, you solve it by this. Phase difference could be anything from here to here or from here to here. But when you solve this expression, you will get to know that you need to put the value of n equals to negative. If you put n equals to negative, then your answer will be matched. So let's solve it. Let's solve it. We have the page. We have to add another page. So what I mean to say is that if I had taken my phase difference equals to opposite. What is that phase difference? Pi by 2 minus beta by 0 minus beta d by 2 minus pi by 2. 0 minus beta d by 2 minus pi by 2. If I had taken the phase difference like this, then what will be the phase difference? Pi by 2 minus beta d by 2. What will be the location of maxima? Location of maxima would have been pi by 2 minus beta d by 2 is equals to 2n pi. So from here what we are getting? Beta d is equals to 1 minus 4n pi, right? So d will be equals to 1 minus 4n lambda by 2. Okay. Now if you see here, if you put n equals to 0, what is the value of d you are getting? Lambda by 2, which is acceptable. But if you put n equals to 1, what you are getting? D equals to minus 3 lambda by 2. which is not acceptable. If you put n equals to -1, then what you are getting? If you put n equals to -1, then you are getting 5 lambda by 2, which is acceptable. So here also you are getting the same answer. That's why I said that n value could be positive, negative, anything. But in one of the cases you will get the correct answer, whether for the positive case or for the negative case. In this case you are getting for positive case, here you are getting for the negative case. So any phase difference you can take, plus minus anything, that doesn't matter. So answer would be 50. Well and good. Let's solve the next question. All these are gate PYQs only. So for an infinitesimal small dipole in free space, the electric field E theta at the far field is proportional to this thing that we already know, right? And a vertical infinitesimal small dipole, electric dipole is placed at a distance h above the height ideal conducting. So this is a conducting plate and above height h, this another dipole antenna is placed as shown in the figure. Find the minimum value of h for which the maxima in the far field radiation occurs at theta equals to 60 degree. So this theta equals to 60 degree they are giving as a reference. So maxima is occurring at theta equals to 60 degree. This is a conducting plate. So one thing from, if you see the conducting plate, what should click to you? Conducting plate is there, ground. Above this, you are having an antenna at height h. Right? If this is ground or conducting plate, if this is a conductor, and I am finding electric field component at P. So will the electric field component will be there because of this guy only, or there will be something else as well? I told you, whenever there is a conductor, what we need to do? We need to take the mirror image at the same distance. At the same distance, we need to take the mirror image. And if you remember clearly, then if the current is like this, and I take the mirror image, then the direction will be opposite. But if the current is like this, and I take the mirror image, then direction will be same. Say yes or no. Right? If you remember, this was our plus Q. This was our minus Q. So plus Q will be replaced as minus Q will be replaced as plus Q. Again, the direction is upward only. So projection of this point is here, projection of this point is here. So this is the projection. This is another antenna we are getting. This is one of the antenna, another antenna we are getting, but the but the direction of current is same. If this is having I naught current, this is also having I naught current. You will never write that, sir, current would be I naught e to the power j pi. But if this is having I naught current, then how much current this is having? E to the power j pi current this is having. Are you getting this point? So let me write down a simple note. What is that note? That this is a conductor, this is a conductor. What this is? This is ground, you can say. This is also ground. If your antenna is lying this and antenna is lying this, then I will make the mirror image. How I will make the mirror image? For this one, I am making the mirror image in this direction only. For this one as well, I am making the mirror image in this direction only. And now this is given that this is having I naught current and this is also having I naught current. So for this mirror image, this will have I naught current only. But for this mirror image, this will have I naught current, which I am showing in this direction. But actually it is opposite. So that means it is having a phase of pi. But here there will be no phase difference because there is a conducting plate. So same mirror image is copied. Is that clear to you? And what they are saying, at the angle 60 degree you are having the maxima. So maxima minima they are talking about. That means you only need to write down the array factor. So this is the angle 60 degree. So let's write down the array factor. How will you write down the array factor? So at the origin I have assumed a current source having at the origin I have assumed a antenna having current I naught and having phase of 0 degree. So with respect to that, if I call this as antenna 1 and this as antenna 2, so how will I write down my array factor? So e to the power j. This was having a phase of 0. This is also having a phase of 0 degree only. So 0 degree. E to the power j beta. From the origin, I will join this point. From the origin, I will join this point. From the origin towards this. This is my h vector and this is my ar vector. This is my ar cap vector. So h dot ar, what that would be? Beta h vector dot ar cap cos theta. Say yes or no. Did you understand this point or not? This vector and this vector, what is the angle between them? 60 degree. So cos theta. Simply what I am doing, I am taking dot product between two unit vectors. So this is the first thing. Second thing, a to the power j. Here what will be the phase? Again 0 degree, because this is also in the same direction. All these three currents, this antenna 1 current, antenna 2 current, and the imaginary antenna at the origin, all these are having the current equals same magnitude and in the same direction as well. I naught, I naught, I naught. So a to the power j 0 degree. A to the power j beta from the origin towards the antenna. From the origin towards the antenna. So this will be my h vector. So h dot ar, if I do, here I should have made it from the origin towards the antenna. So if I do h dot ar, then how much angle will be coming into action? 120. So here what I am going to write down? H cos 120. Okay. So this will be my array factor. So cos 60 is 1 by 2, and certainly cos 120 is minus 1 by 2, because this is equals to cos 180 minus 60. So that is equals to minus 1 by 2. So what is my phase difference? So my phase difference here is, from anywhere I can take the phase difference. From here to here I can go, or from here to here also I can go. I am going from beta h by 2 to minus of minus beta h by 2. So my phase difference is beta h. What they are saying? They are saying maxima is occurring, no? The minimum value of h for which maxima is occurring. So for maxima, if they are talking about maxima, then this should be equals to 2n pi. So from here what I am getting? 2 pi by lambda is equals to 2n pi. Into h is also there. 2 pi by lambda into h is equals to 2n pi. So 2 pi get cancelled. H is equals to n lambda. Right? 2 pi gets cancelled. H is equals to n lambda. And do they have given the value of lambda? Okay. In terms of lambda only the answer is given. So n value what you are going to put? Minimum value of n is 1, not 0. Minimum value of n is 1. So h is equals to lambda. Lambda 2, lambda, all these could be the answer, but they have asked the minimum value. So answer would be h equals to lambda. Right? So this would be the answer. Very easy question, just see the geometry and start following it. That's it. Very straightforward, nothing is there. Right? Solve this question. The answer was given this one, but whatever the answer that you get, that you need to find. Try solving this question. In these kind of questions, always make the 3D geometry. What is our target? Whenever you see a question of antenna, always make 3D geometry. Because here one current is going inside, one current is going towards you. So better make the 3D geometry. Always make 3D geometry. This was the answer given, but I don't think this answer is correct. Okay. As per my opinion, this answer is not correct. So try solving it. Get the answer on your own. Then we will solve it from our side. Okay. So again, I need to pause the video. Then we will start solving it. Yeah. Welcome back, guys. So did you attempt this question? So what they are saying, two identical antennas are placed in the theta equals to pi by 2 plane. What do you mean by theta equals to pi by 2 plane? Let's make the 3D geometry. This would be my first term target always. When I see a question like this, then here the antennas are going inside or outside the plane. So better I will make, always I will prefer making 3D geometry. Z axis, and how do I make my 3D geometries? Z, Y and X. This is always, this is my Z, this is my Y and this is my X. And what is the theta? Theta is the angle measured from Z axis. So they are saying theta equals to pi by 2. That means what is this? This is your XY plane. Say yes or no. Theta equals to pi by 2 they are saying, no. So this has to be your XY plane. Now they have shown the phi. They have shown the phi angle. So phi is the angle measured from X axis. So this will be my X axis and this will be my Y axis. Why it is XY plane? Because theta equals to pi by 2. So from Z axis you are going pi by 2. You are going 90 degrees. So you are reaching on XY plane only, no. So that's why. Now on X axis, if this is your X, this is your Y, where will be your Z? X cross Y towards me. Z will be outward. So this will be your Z. Right? Now if you see this element, so this is going inside the screen. This element is going inside the screen. So on X axis you are having an antenna which is in minus Z direction. What this is showing to? Minus Z direction. And what this is showing to? plus z direction, because this is along the plus z direction. So if I show the antenna, how will I show it? I will show the antenna in this manner, that on y-axis you are having an antenna. On y-axis you are having an antenna where the arrow is in plus z direction. Although the arrow doesn't matter much, but this is how I will show it. On y-axis you are having an antenna which is placed along z-axis, because this is how the antenna are placed. If this is my y-axis, so this is how the antenna is placed. This is how the antenna is placed. So it is placed along z-axis. It is placed on y-axis and placed along z-axis. So this is placed along z-axis. Similarly, on x-axis as well there is an antenna. On x-axis as well there is an antenna which is placed along minus z-axis. So if this is my plus z, then where will be my minus z? This is how my minus z would be there. Basically, what they mean to say is that if this is having I naught current and 0 degree angle, then this is having I naught current and pi degree angle, not pi degree, 180 degree angle. Are you getting this point? But if I am showing by pi degree angle, then I need to show the direction opposite. So I hope you are able to understand the point. So this is having I naught current, this is also having the same current, but they are phase shifted. So that's how they have shown this antenna. Now let's see what they are saying. The elements have equal amplitude excitation with 180 degree polarity difference. They have written down as well that they are having a polarity difference of 180 degree, operating at the same wavelength. Amplitude is also same. That means both are having I naught current only. The correct value of magnitude of far zone resultant electric field strength normalized that of a single element, both computed for phi equals to 0 degree is. What they are saying? They are asking the magnitude of the far zone resultant electric field. Let's read this line carefully. Magnitude of, one second guys. Yeah, so what they are asking the magnitude of the far zone electric field strength normalized that of a element, that of a single element. So let's read this line carefully. Magnitude of far zone resultant electric field normalized with that of a single element. What do you mean by this line? So what is the electric field we write down? Because of antenna array, there are two antenna, that means it is a two element antenna array. So what will be the electric field that we will write down? Electric field due to single element at origin into array factor. This is how we write down, right? This will be our resultant electric field at far zone. Now this is normalized with that of a single element. What do you mean by that? What do you mean by normalization? When we were writing down normalized electric field, when we were studying this radiation pattern, at that time we wrote down the normalized electric field. What did we write down? Magnitude of E divided by the maximum value of E. This is what we did. Magnitude of E divided by the maximum value of E. When I was writing down the normalized load impedance, in Smith chart, so what did I do? ZL by Z naught. So I was normalizing it with respect to Z naught. I was normalizing it with respect to E max. So now they are normalizing it with respect to this guy, because what they are saying, normalized with that of a single element. That means it is normalized with the electric field strength of a single element. And what is this? This. So what actually they are asking? What they are asking? They are asking the magnitude of electric field at far zone due to two element antenna array normalized with single element antenna array. This is what they are asking. Sorry, I said single element antenna array. Really sorry. I should have said due to the single element at origin. This is what they are asking. And what is that equals to? Mode of antenna factor. So they are asking nothing but the mode of antenna factor only. Electric field normalized with the single element electric field. Total electric field normalized with the single element electric field. This is what they are asking. That means they are asking the magnitude of array factor. Do you get this point or not? So I need to calculate the magnitude of array factor, and that I know how to calculate, right? So very easy thing. And the second thing what they are saying, both computed for phi equals to 0 degree. That means your R point, your point P, where is your point P? Sorry, yeah. So what they are saying, both computed for phi equals to 0 degree. That means where is your point P? Your point P is at phi equals to 0 degree. And where is phi equals to 0 degree? XZ plane, theta equals to 90 degree. Which plane? XY plane. And phi equals to 0 degree. That means phi is 0 degree. Here phi is 0 degree, no? Because from here phi starts. From here phi start. If phi is equals to 0 degree, that means they are talking about xz plane. So your point P is in xz plane. Here is your point P. This is what they are saying. So let me make the point P in a better manner. So point P will be somewhere here. This is what they are saying. So what I need to do? What is the first task? So if I show it by arrow upward only, if I show this antenna by arrow upward only, then how I can show it? If I say that this is having a current of I naught, then this will have a current of I naught having a phase of pi or minus pi as well, because pi and minus pi both are same thing, right? Now what is our target? I will assume a antenna at the origin, an imaginary antenna at the origin. Let's move this phi. I will assume an imaginary antenna at the origin having a current of I naught and 0 degree phase. But do I need to write down the expression of ESO? No. So I will not write down the expression of ESO. I will only write down array factor. So let's write down array factor. So what will be my array factor here? My array factor would be e to the power j. If I call this as element 1 and this as element 2. So e to the power j, how much lead this current is having with respect to the current at origin? How much phase this current is having? Pi. E to the power j beta from the origin or from the origin towards this. From the origin towards antenna 1. What I will do? I will assume a vector. From the origin towards antenna 1. What I will do? I will assume a vector. And what is this distance? This distance is s. This distance is s. From the origin towards the antenna, I will assume a vector, that is s vector. And then AR cap. Where is my AR? My AR is here. This is my AR. Say yes or no. I will write down the current downward. The current is I naught e to the power j pi. So where is my AR cap? This is my AR cap. Like this is a far field point. So this will be AR cap for this guy. And for this guy, this will be the AR cap. So this is how the AR cap is going. Are you getting this point or not? So here I can solve by geometry as well, or I can go with the simple method. Like what is this angle? This angle is phi. So if you see what is the angle between S vector and AR vector, that is cos phi. But let's solve it by geometry. So what is your S vector here? This is your S AX cap. Here what you will write down? S AX cap dot AR cap. Say yes or no. Do you agree to this point? Right? Plus e to the power j. How much phase shift this is having? 0 degree. 0 degree. E to the power j beta. Here what I am gonna do? Here what I am gonna do is that again the same thing. From the origin towards antenna 2, I am making a vector. What is that vector? S AY cap. That vector is S AY cap. Distance is S only and the direction is AY cap. So S AY cap dot product with AR cap. Because this AR cap, this is also AR cap and this is also AR cap. But with dot product we do with this AR cap only, with this AR cap. So S dot AR cap. So S dot AR cap. So what you will get? Array factor e to the power j pi, e to the power j beta. What is AX dot AR? AX dot AR. If you remember AX dot AR, sin theta cos phi. So here what I should put? Sin theta cos phi. Sin theta cos phi. Right? Here I showed this angle as phi. That is wrong. Really sorry. Big blunder from my side. Why I called this angle as phi? No. This angle would be phi, no? This angle will not be phi. This angle will be 90 minus theta. Right? This angle will be 90 minus theta. Because from the z axis the angle is 90 degree. From the z axis angle is theta. So this angle would be 90 minus theta, no? So that was a blunder from my side. I should not have put that. Now here phi is equals to 0 degree. Everything we are computing with phi equals to 0 degree. Say yes or no. Here on this plane we are computing. Our point is on this plane. So this we are computing with respect to phi equals to 0 degree. Do you agree to this point or not? Yes, I agree. So cos phi. So in the next line I will write it down, because phi is equals to 0 degree plus e to the power j 0 degree e to the power j. Here s I forgot. I forgot the value of s. S also I need to put. S also I need to put. Ay dot ar. What is ay dot ar? Sin theta sin phi. Right. So what is phi? Phi here. Phi is equals to 0 degree. Here phi is equals to 0 degree. Will you put theta equals to 90 degree? No. Here I need to write down for point P. Point P is computed for phi equals to 0 degree. Now for point P, is it necessary that theta is equals to 90 degree? No. Theta could be anything. No. What I mean to say is that this is my ZX plane. 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 ZX plane. Now point P could be anywhere. If the point P is on x-axis, this is my ZX plane. If point P is on x-axis, then I can say my theta is equals to 90 degree. But point P could be anywhere, no? Here. So for that there will be some specific theta. So theta should be remained there as it is. But if you are computing on ZX axis, if you are computing on ZX axis, if you are computing on ZX axis, that means here your phi is certainly 0. That what I mean to say is that on ZX axis, if you take any point, if this is my Z and this is my X axis, if I take any point on ZX axis, at all the points phi is equals to 0 degree, say yes or no. So here I am not going to put the value of theta as 90 degree. I am going to only put the value of phi equals to 0 degree. Why did I put the value of phi equals to 0 degree? Because you need to think about the point P where you are finding. So where is my point P? My point P is in ZX plane. I said ZX axis, sorry for that. My point P is in ZX plane. And if my point P is in ZX plane, that means for all the points there, point P could be any random point. But for all the points there, phi will be 0 degree. So without any doubt, I can put phi equals to 0 degree here. But if my point P is in ZX plane, then I cannot say that my theta will always be 90 degree. It will be theta equals to 90 degree only if the point P is on x axis. Because if the point P is on x axis, that means complete theta will be equals to 90 degree. But here this theta can be any random angle. So that was the mistake that was done by the question paper setter as well. Okay, they also took theta equals to 90 degree. Because if you take theta equals to 90 degree, then you will get the correct answer. But here theta should be put as it is, right? Theta should be put as it is. So theta equals to 90 degree should not come there. So this is what we are getting. If we put phi equals to 0 degree, then what you will get? Sin 0 is 0. Sin 0 is 0, so this term will be 0. And this is already 0. So this term will be 1. E to the power j0, 0. Beta sin phi is also 0. So this complete term will be 1 only. So what you are getting? E to the power j beta s sin theta. What is cos phi? Cos phi will be 1 and plus 1. Say yes or no. Right? So this is the array factor we are getting. Now the answer was given this. So all the options are in sinusoid only. So now I need to get a sinusoid out of it. Sinusoid or cosinusoid. Options were sinusoid or cosinusoid. So what I can do? One thing I remember, what is that? That my cos theta is e to the power j theta plus e to the power minus j theta divided by 2. And another thing I remember is that e to the power j theta minus e to the power minus j theta divided by 2j is equals to sin theta. So I will try to get this expression. My target would be getting this expression. So how I can target getting this expression? So what I can do is that e to the power j pi by 2 e to the power j beta s sin theta by 2. This I can take outward. So here what I will be left with? E to the power j pi by 2 e to the power j beta s by 2 sin theta plus e to the power minus j pi by 2 e to the power minus j beta s by 2 sin theta. Right? Here I just took this outward. Now if I divide it by 2, what I am getting? This will be equals to cos some angle, right? And this is as it is. So this is my array factor. So my array factor is coming out to be e to the power j pi by 2 e to the power j bs sin theta by 2 and cos of this particular angle, because what is this? E to the power j theta 1 plus e to the power minus j theta 1 divided by 2, e to the power j alpha plus e to the power minus j alpha divided by 2. So cos pi by 2 plus beta s by 2 sin theta. Right? Now let's do more. So for that we need to add a page. So array factor is coming out to be e to the power j pi by 2 plus, what is this, beta s sin theta by 2, beta s sin theta by 2 cos pi by 2 plus theta, what is that, minus sin theta, right? So minus sign is there, minus sin theta, because what is cos theta, cos pi by 2 plus theta is minus sin theta, so minus sin beta s by 2 sin theta. But what do I actually need to calculate? I need to calculate the magnitude of array factor. What will be the magnitude of array factor? That would be sin beta s. What is beta s? 2 pi by lambda into s by 2 sin theta. So what we are getting? Sin pi s by lambda into sin theta. And 2 factor of 2 is also there, no? Somewhere I am missing the factor of 2. Yeah, so if I am dividing by 2, I need to multiply by 2 as well. No? I need to multiply by 2 as well. If I am dividing by 2, I need to multiply by 2 as well, right? So here multiply by 2, here multiply by 2. Because magnitude of this guy will be 1. A to the power j anything, e to the power j alpha, magnitude will be 1. So magnitude of this guy will be 1. This 2 will come as it is, and this guy will also come as it is. So this is what we are getting. So this should have been the correct answer. This should have been the correct answer. But as per the given answer, this is correct, okay? But as per the given answer, point P is on x-axis. And if point P is on x-axis, that means phi is equals to 0 degree and theta equals to 90 degree. Phi equals to 0 degree was given, but theta equals to 90 degree was given only for the orientation of antenna, not for the point P. Point P I can assume. The orientation of antenna was given for theta equals to 90 degree, but phi equals to 0 degree was given for point P. This was already given. This was also given, but this was given for the orientation of antenna. But this was given for the this was given for the point P. They were saying that point P is in ZX plane. The point P is in ZX plane. This is what they were saying. So phi equals to 0 degree and 90 degree were also given, but this both they have took for finding this out. So your array factor would have been 2 sin pi by s lambda. What is sin 90? Sin 90 is 1. So this would have been the answer. But if this question is framed right now in 2025 or in 2026 or 2027, then at that time I am pretty sure this option will be mentioned, not this option. This option will also be mentioned, but this will be wrong. Why this will be wrong? Because you need to see the point P. For the point P, your phi is certainly 0 degree, but theta is not equal to 90 degree. Are you getting this point? Now, one more thing I can teach you here is that here I solved it using that particular formula, but without even using the formula, I could have solved it. How? Let's check that out. So here what I need to do, s dot ar cap. What I need to do, s dot ar cap. So this point P is in xz plane. The point P is in xz plane. If this is my z axis, black one, this is my z axis, and this another pen, this is my x axis. So point P is somewhere here on my palm only. On my palm, point P is there. So if you join this point P, and this is your AR cap. So what is the angle between this S vector and AR cap? That is 90 minus theta. Right? The angle would be 90 minus theta. So here the angle would be 90 minus theta. So AS dot AR would be cos 90 minus theta, that means sin theta. So here what you are getting, sin theta only. So you don't need to write down these expressions. Using the geometry as well you can solve. Now another one. What about this one? S vector and AR vector. Now where is my point P? Here is my point P. So this is my AR vector. Where is my point P? My point P is on this palm. Where is this point? Where is my antenna 2? This is on y-axis. So any point on my palm, and then this is the vector. One vector is on my palm. You can see this is my palm. On my palm I am drawing one vector. One vector is on my palm. And another vector is this one. What is the angle between both of the vectors? 90 degree. Because this axis or this plane is perpendicular to this axis. So angle is 90 degree. And if the angle is 90 degree, that means what will be the dot product? Dot product will be 0. So here what will come? 0 will come. So without even using that particular formula, you could have solved it using the geometry as well. But in the examination, if geometry doesn't click, then you can solve it. And if you have studied coordinate system from PrepFusion, then I am 100% sure that this would have clicked to you already. Right? This would have clicked to you already if you have studied it in a good manner. Say yes or no. Right? So by geometry you could have solved. Both are perpendicular, so dot product 0, and here both are having the angle of 90 minus theta. So here cos 90 minus theta, which is sin theta. So in the examination, if I have good enough concept, then directly I would be writing this step. I wouldn't be writing all these steps. Within 1 second I would be writing this step only. Not within 1 second. Within 20 to 30 seconds I would be writing on this step, and then I could have wrote down this step directly, and from there I would get to know this would be my answer. 2 cos pi by 2 plus theta is sin theta. So 2 sin theta beta s by 2 sin theta. So here I would have reached very quickly. But in the examination, I would be getting confused that why they have taken theta equals to pi by 2. But I have explained it that it is absolutely wrong. They should not have taken theta equals to pi by 2. Theta equals to pi by 2 will be taken only when the point P is on x-axis. So yeah, that's it about our 2-element antenna array. Next, we need to see the radiation pattern. That how do we draw the radiation pattern? Here we have find out electric field maxima, minima, all those points we have find out. Now we will see the radiation pattern. So this is also very important topic. So this we are going to cover in the next lecture. So in the next lecture, we are going to see the radiation pattern and n element antenna array. So till now we have seen only two elements. But what if n elements are placed? So that also we are going to see. And broadside array and end fire array, those arrays also we are going to see. So next lecture will also be very interesting. So I hope you enjoyed it. If you have enjoyed it, then do share it and like this particular session. Thank you.